Okay, I'm going to go over the cam side of Titan 8M, the little eyeglasses. So slightly different than the way Titan is doing it. He started off with the drill and then the face mill. We're going to do face mill first and then the drill. So if you check your setup sheet here, right here, 8M. So we're going to start with the face mill just like it's listed here. We're going to use a 1/2 inch, but we're going to call it a stubby or a screw machine drill. It's going to be short drill, and we're all using it to pre-drill. And it's also going to create the holes in the middle, but also give us another entry point to get into the inside. Then we're going to use the standard 1/2 inch 3-flute end mill. Going to bring back the key cutter again, and then finish it up with chamfer mill. So we're going to use the typical upper left corner. All right, put down the setup sheet. All right, so here's the model that's done, and the setup was Op1 and upper left corner, typical setup. It's about 5.5 inches long, 1 inch tall, 2 inch wide. And I got it labeled as 1001 and Titan STC Op1. Okay, so we're going to start with face mill first. And then we're going to do the drill. We're just going to flip-flop those. So the face mill is pretty typical. I'm going to shut off some of these eyeballs here. So this is face mill only, and just to go over a few things, I'm pulling my tools out of the newer library. So in my tool selections, I have Titan building block aluminum tools, the STC library. This is the original library, and now we're using the Titan building block aluminum tools. So you're either updating an old program or starting new. Just pick milling, and right here would be your list of tools. In this case, this is my tool list right now. I have 5 tools, so I'm using this as my tool 1. Okay. And let me unfilter this. All right. So when I come in here, I pick the face mill default, which gives me these feeds and speeds at 2,500 feet per minute, and cutting feed rates are going to be somewhere around 40 inches a minute. Stock selections, let me just reorient this. Typical model top, and personally I don't use the vertical lead in, I have it just go straight up. Alright, so this is first cut. Then we're going to do the drill. This is going to be the drill. We call it a 1/2 inch stubby drill. And this is going to be peck drilling. Normally we always prep a hole for the drill, but this is short, so this could still stay on center. So I'm selecting the 1/4 inch drill. So if I'm in this library here, it would be hole making, right here, 250 HSS stubby drill. I picked that, and I have the preset for that, so that gives me all the RPMs and stuff. And this would be 250 feet per minute, which calculates out to 3,800 RPM. And the feed per revolution is 4,000, which gets us 15 inches a minute. We're selecting the tool hole faces down here. But remember, it's all solid at this point, so we're not going to go all the way to the bottom. So you're going to use model top for the top height. And then bottom height, you can do a couple different selections. I used whole bottom, and I said drill tip through bottom and then break through 100, which is going to give us this. So the point of the drill will come through the bottom. Let me recenter this again. And you're going to use deep drilling, which is the pecking cycle, G83 pecking cycle, and 0.100 will give us our pecking increment, which is the Q value in G code. So that's the deep drilling. Then we're going to go to 3D adaptive. I'm going to use the newer building block aluminum milling, and that would be the STC 3-flute end mill, which is the AccuPro end mill. We're going to use the adaptive preset, which gives us 5,900 RPM at 62 inches a minute cutting feed rate. Stock contours, these are all your typical settings. And model top, model top, model top, and model bottom, and minus 10 thousandths. You can also use model top minus 760. Either one of those would work. But you can see right here where it ends up, minus 760. Okay, now we got optimal load. Because we selected adaptive, this is already set for us. The sideways load and the maximum step down. And we're going to leave stock to leave 5 on the sides and 5 on the floor. 5 thousandths. And I like to set the 70%, have a lift height of 10 thousandths, and set the non-engagement feed rate at 400. But this way, we're not going to ramp mill in there. We're going to pick pre-drill positions. So right up here is pre-drill. I pointed out there. Let me flash that up there. Pre-drill locations. So it's because the holes are already drilled, we're gonna enter through the hole. We're not gonna spiral in. All right, hit OK. So right there is our entry point, how it's going to get in there. And these are the cuts that go around it. All right, the next one we're going to do is contour cutting. So you're actually going way down in here to do that wall. So same thing, we're using the new STC tool with contour preset. And the geometry selection is way down there, right? So we're just going to spin around a little bit. That hole's a little bit bigger than 1/2 inch. So because it's a 1/2 inch drill, the 1/2 inch end mill will fit in there and spin around. And it'll be selected contour and add -10 thousandths. And very small lead-ins. The next one will be the outside contour right here. And that would be the same STC tool with contour preset. Same RPM and feed rates. And this is your geometry selection, which is right there. Right? All model tops and selected contour, 10 thousandths, and everything else pretty standard. We also have to finish machining the bottom pocket, which is right here. Make a nice flat surface. So that's going to be same thing, but you're going to use pocket selection now. And you got to pick these two boundaries. Model top, and you selected contour. That will control the height of the depth of the pocket. And I like using wear compensation. That gets you your G41 cutter comp. And left climb milling. And the last one would be the lead-in, lead-outs, which are these little lines right here. And we're also following the, it says right here, pre-drill positions. That's going to be your entry. So let me review the other ones, make sure they're not in pre-drill positions. They're not, that one's not following it because it's outside. And this one seems to be on center already. Yeah, it is. Okay. Contour. This is actually the T-slot cutter now. This will be this big cutter right here. All right. So to control the depth, and we're going to use it's going to be the preset STC slot if you're pulling tools out of the aluminum library, which would be this one here, STC T-slot and picking slot, or using the preset up here. So it's going to be 825 RPM. This is going slower. The geometry is this inside chain, way inside there. And the heights, we're going to use selected contour for our depth selection. And we're going to leave this on in computer for compensation. And this says roughing passes, because this is going to be maximum step over, that's going in, smoothing deviation, and number of step overs 2. So you can see right, this is where the tool path is going to be. So it's going to loop in and come back out so it can clear coming out. And make sure these lead in, lead outs have a little bit of room at 0.1. All right, and then we're going to do chamfer the top. Same thing, we're going to pick the upgrade to the aluminum 3H chamfer mill and use the chamfer settings. There's no drilled or tapped holes in this one. Here's your geometry selections for the top, 1, 2, and 3. So this would be model top on height. And chamfer width 0. Now if you're going to the inside line, leave this on 0. If you add 10, it's going to be very wide chamfer. It's going to be oversized. All right. The last one is a chamfer way down the side here. This area, big fat chamfer. All right. So same tool with the chamfer preset. And these are your selections right here on that outside wall. Select a contour for depth. Same thing, use chamfer width of 0 because that's going to align with this edge. So you need to pick the outside edge. And lead in transitions, all right. So let's do a quick simulate. Cut the top. Then we drill the holes. Then we rough the outside with adaptive. Notice that, let me slow this down a little bit. I'm going to back up. All right, go forward again. Forward. So the pre-drill is going to go down the center of this hole, and that will be, that hole doesn't look big enough. You know what? Deep drill. Let me check the library here. That's this 1/2 inch solid carbide. I did not use the correct drill. That would have worked sort of, but let's fix that, right? All right, select drill. That's incorrect. I need to go back here and get the bigger drill. which I do not see in here. Oh, here it is. 1/2-inch drill right there. Wrong drill. All right. Faces, model top, goes through the bottom. Yep. All the same setting. Okay. Here we go. Simulate again. Press play. There we go. Much bigger drill. All right, now I'm going to follow the plunge holes. That'll be our entry in. I wonder why I did it twice. I'm going to see if I can fix this. Hang on a second. Okay, I didn't discover anything wrong there, so it just looked a little funny to me, but I think it'll work just fine. So I'm going to jump ahead. This is the jump ahead. Jump ahead. I'm going to do colorization by comparison. So everything that's blue needs to be cut, and everything green is done. Jump ahead. Let me go back one operation. I want to observe this one. Pull this out of the way. Alright, so that's a whittle away that. I really want to watch these pre-drills. Alright, whittle that away, that away. Goes right down the middle. So I was wondering why it was going in a second time, but it's actually doing it at different depths. So if I look up close on this, it actually did it at 3 levels. So that I think that's going to be acceptable. All right, now we do the finishing. Finish, finish. Finish the outside. Finish the floor. All right, now we do the T-slot cutter. That looks good. No blue left. Chamfer the outside, so we got a little bit of chamfer to do in there. Yep, that all looks good. This is the deep chamfer. Same tool, but alright, that looks fine. And my operation time, let me get out of simulation, would be 5 minutes 36 seconds with the okay. And I'll pick up with Op2 in a second. Talk to you later.